So now we're going to look at some notation for antiderivatives and integrals. So remember antiderivative, the word, that's easy to understand. It's kind of the reverse derivative. So that's a good word because it tells you exactly what it is, but it's a synonym for integral. And this chapter is called integration, which is the process of finding the integral. So we learned on the video before the antiderivative of 2x is x squared because the derivative of x squared is 2x. So notation. This is called the integral sign. It's like a big elongated S, and it means antiderivative. So we can also say the integral of 2x. And now right here, I'm going to write this dx. That means with respect to x. That's just like when we did dy dx. That was the derivative with respect to x. That's what the dx meant. That's also what it means for an integral or antiderivative. And we know this is x squared. But the is not a really good word to use here because we can also say the antiderivative of 2x is that, because the derivative of x squared plus 33 is 2x. So you could also say the integral of 2x equals x squared plus 33. Now, obviously, 33 was just an arbitrary number I chose. You can choose any constant number. So since the antiderivative or integral can be really an infinite number of answers, the one thing that's sure is it's always x squared plus or minus something. So we're going to say it's x squared plus c, which represents any constant number. It's called the constant of integration. So these are also called integrals. More specifically, these are called indefinite integrals. Indefinite integrals. We are going to learn about definite integrals later on, but indefinite integrals, a good thought about why they're called indefinite is because they don't give you like a definite answer. You always have that plus c involved. So this is the notation for an antiderivative or an integral. And this whole process is called integration. And at this point, you may think, well, this is kind of a guess. Like you're going to have to, when we play Jeopardy, you're going to have to kind of somehow figure out what the derivative, whose derivative will get you this answer. And we're going to try to come up with a formula on the next video to make it less of a guessing game. But integration is going to be kind of more complicated than differentiation. There's not going to be so many rules here. So you'll see when we get there. I've probably talked too long in this video already. The next video will be looking at a rule for integration that will help us out at least a little bit.